Alright, so let's not beat around the bush. Question 10 is tricky. Tricky? Something like that? It's a hard question. But I should qualify that you should still be able to pick up a few, I don't know, easy marks, alright? Marks that you'd be able to get if you were in further or even year 9. Oops, AR, year 9. Alright, so let's not overcomplicate things. Yes, it's tricky, but I think you should be able to pick up easy marks that, year 9 students could almost get. So let's get into it. So the figure shown represents a wireframe where ABCE is a convex quadrilateral. So blah, blah, blah. This guy has right angles. That's what it's telling you. And again, that's all up there as well. The point D, well, where's D? Let's have a look for it. So D occurs here, is on a line segment with EC, with AB here, equaling ED equaling 2 centimeters. Alright, so that's all on the diagram for us. That's not too bad. And finally, BC, so put that here, is A centimeters. So let CBD equal theta. That's, sort of this guy here. And it's between 0 and pi on 2. So it's an acute angle. That's all that's trying to say. It's an acute angle. So something like that. Not 90, but not 0. Alright, so the first thing we've got to do for part A is to find BD, which is this segment along here. So put that one in blue, even though we've got other things in blue, but that's the BD bit that I'm looking at. And CD, I'll put in orange up here, and that's CD. So it says we're allowed to leave it in terms of alpha and theta. So our angle and that hypotenuse length. So all we've got here is a nice right-angled triangle. That's what that little black bit there says. It's a right angle. So we've got lots of things we can do with a right-angled triangle. So from year 9, you should have learnt something like Koa, and maybe even a bit of Pythagoras. So I don't think we'll need Pythagoras here. I think we'll use these guys. So if we want to look at CD first, so CD was our orange bit, so CD, we have an opposite side length and a hypotenuse. We've got an angle, an opposite, and a hypotenuse. So I reckon we're going to use sine of that angle is equal to the opposite, CD, over the adjacent, A. So when we clean that up, we just get that CD equals A times sine theta. Now the blue BD, oops, sorry, made a mistake there. That's BD. We know we've been given, an angle. It's adjacent to that angle. It's down here. And we've also got the hypotenuse. So I reckon we're going to use cos theta equals adjacent BD over hypotenuse A. So when we clear that up, we're just going to get that BD is equal to A cos theta. Alright, so A times cos theta and A times sine theta are the two bits we're looking for. And again, not too hard. Pretty easy to be scared off easy marks in these types of questions. So you really need to just break it down into easy bits that you can deal with. Alright, so a third of the kids, 1/3, 34% I should say, didn't get any marks. Alright, no marks at all for 10A. So hopefully you can slide into here with some easy maths. Alright, so this is just all information we've seen before. That's nothing too scary. So now we want to find the length of the wire of the frame, including BD. So we've got to include this little stretch along here in terms of A and theta. So again, this is almost Year 9 maths. Alright, so we had BD as equaling, I'll just flip back quickly and steal it, A cos theta. So that meant that CD must have been A sine theta. Alright? So now it's just a matter of adding on all these little lengths. So we know that BD is the same there as it is here. So we're going to have two of those lengths. We know this side length here in the green, and the green is 2. So we're going to have two lots of the lengths there. So our length L is equal to the two green ones plus two lots of the orange ones. So the orange ones was BD. So plus 2A cos theta. Then we need to chuck in our alpha, or our A, sorry. And then lucky last, we add in our CD length, which is just A sine theta. Alright, so we're going to need that equation in the next one. So just to simplify that down, I'm going to just turn this into a 4 now. Hopefully you can see that 2 and 2 combine to give 4. So that's our length, and that's 1 mark there. And again, we're up to the stage where, 42% of kids are missing out on what I would think are easy marks. So next we're asked to find dl d theta, or the rate of change of L with respect to theta, and hence showed that dl d theta equals 0 when BD equals 2CD. Alright, I'll agree that that sounds messy. Alright, it sounds really messy, especially when you've got only an hour to do this. So let's break this into two parts. This bit here, part 1, and this bit here, part 2. Alright, the first thing it asks is to find dl d theta. So let's go back to the previous slide and get L was equal to what? 4 plus, I think it was 2A cos theta, 2A cos theta plus, what else do we have? Alpha, or sorry, A plus A sine theta. Alright, so now we're just trying to find dl d theta. Alright, so we're just deriving this expression here with respect to theta. So 4 doesn't have a theta involved, so it's just going to go to a 0. So we're going to have a 0 here. Plus, now, cos theta, if we look at our sheet, the ddx of cos theta, or cos AX in our case, is negative sine AX. So this is going to go to negative 2A sine theta. Alright? Now I don't want you to flip out because there's some, another letter involved. Alright? That's just treat it as a constant. That's just as if it was, 4 cos theta would just go to negative 4 sine theta. Alright? Don't freak out about the A, just leave it in there as if it was a number. Next, we've got our A value here, and it's just going to be a 0, so no need to stress about that. And then we've got A sine theta. So again, let's not panic about this. Don't panic. Just leave it as some sort of constant term. Just constant. Alright? So now, our ddx of sine theta, if we look at it, is just A cos theta. So we're just going to get a cosine theta. Alright, so the zeros obviously disappear, and we've just got dl d theta equals negative 2a sine theta plus a cos theta. Alright, so that's 1 mark there. 1 mark. Yay, we've got 1 out of 2. So you're already in the top, 42%. If you've got to that point. Alright? Another 28 of those went on to get the next point. So that was part 1. And now we're starting part 2. And this bit's actually not too bad. Because all it says is when BD equals 2CD, we should find dl d theta equals 0. So we know from above that dl d theta is equal to negative 2a sine of theta plus a cos of theta. Now, what was BD? So BD, we worked out a long time ago that BD was equal to a cos of theta. Hopefully that's right. Let's just flip back and check. So BD equals a cos theta, and CD equals a sine theta. So if we have from up here, all the way up here, that BD equals 2CD, we can write that BD equals 2a sine theta. So replacing BD here with this value 2a sine theta, we get dl d theta equals negative 2a sine theta plus 2a sine theta, and this cancels with that, and we get that it is 0. So all of a sudden we're at the 2 mark point, and only under 30% of people got there. The average was 0.7. Okay, so question D of question 10, part D, asks us to find the maximum volume of L, a maximum value of L, sorry, if A equals 3 root 5. So if we remember back, L was something along the lines of 4 plus A plus, what do we have, 2A sine, 2A cos theta plus A sine theta. And we're asked to find the value of L if A equals 3 root 5. Alright, so whenever I look at maximum, I think we're going to have to let f dashed equals 0 at some point. So our dl d theta expression was given by something like negative 2 sine theta plus a cos theta, negative 2a sine theta plus a cosine theta. So let's let this equal 0. So now we get something along the lines of, if we rearrange this by adding this to this side, so plus negative 2a sine theta, and we add it to this side, 2a sine theta, they'll cancel, and we'll be left with 2a, adding 2a sine theta equals a cosine theta. Now if we then change our a value to this 3 root 5, so we'll have 6 root 5 here and 3 root 5 here, we'll find that we can write this as tan theta by dividing both sides by cos equals a half. So just to make that really clear, we have that tan theta equals sine theta divided by cosine theta. So when we do that to this this line of working here, we get to tan theta equals a half. Now at that point, we've sort of got to set up our triangle. So if we let theta be this guy here, so tan theta equals a half, which is equal to opposite on adjacent. We have that our opposite value is 1. So opposite is 1, adjacent value is 2. And using Pythagoras, we get that this length here that I'm sort of penciling in green is going to be given by the square root of 2 squared plus 1 squared is the square root of 5. So this is root 5. So from here, we can break down exactly what cos theta and sine theta are. So let's start with cos theta equals A on H. So the adjacent to it is 2. The hypotenuse is root 5. And then sine theta is something along the lines of opposite, which is 1, divided by hypotenuse, which is root 5. So we've now got all the information we need to work this out. So I might just move that up. Say sine theta equals 1 on root 5. So that's just the same thing as I had before. And now we'll work out the length. So the length is going to be given by 4 plus. Now we're going to change this A to be 3 root 5. So plus 3 root 5. Plus, what have we got next? 2A cos theta. So the 2 by the 3 root 5 by cos theta, which is 2 by square root of 5. And then onto that, we add our A sine theta. So A is again 3 root 5 by sine, which was 1 on root 5. We should get that that's equal to 4 plus 3 root 5 plus, what's this, 4 by 3 is 12, and the root 5s will cancel, so that and that go, and we're just left by 2 by 3 by 4 is 12, so plus 12. And then we just get the root 5s cancelling again on here, and we get plus 3. So plus 3 there. So our answer should be 4 plus 12 is 16, plus 3 is 19, plus 3 root 5, and that's our maximum value of L, just there.